Okay, today we're going to be looking at some more parabolas. We're going to be writing equations in standard form using complete the square. We're also going to be looking at the intersection of a parabola and some other type of graph, and we'll see one more example of what could occur when we do that. So, first of all, if we look at writing in standard form, if I give you the equation y squared plus 8y minus 8x plus 40 equals 0. One of the first things you'll notice about parabola equations in general form is only one term is squared. So if you notice here, we only have the y squared. We don't have an x squared. So on these, the first thing you're going to do is move the constant and the extra variable. So here I'm referring to this 8x as my extra variable, the negative 8x and the 40. Because there's not another x, there's two y's but only one x, that's what we're going to move. So we'll have y squared plus 8y, and that's going to equal, when we add 8x to the other side, positive 8x. Hold on, we don't need that. So we're going to add 8x, and then we'll subtract 40, so we'll have 8x minus 40. The next thing we're going to do is we're going to add our blanks. So we're going to add b over 2 squared to both sides. Okay, so we'll come in here and we're going to add in our blank. So plus blank, making sure you do it on both sides. That blank is always equal to b divided by 2 squared. So here my b is 8. Divided by 2 is 4, squared is 16, so we'll add 16 to both sides. Step 3 is factor and simplify. Simplify, there we go. So my y side will factor to y plus 4 squared. On this side we have 8x, and then negative 40 plus 16 is negative 24. The last thing you want to do is we need to get this into 4p form. Here we have my y minus k squared, but this is right-hand side is not set up into 4p times x minus h form. So in order to do that, we're going to pull out common factor. So pull out common factor to get in 4p form. Okay, so we still have y plus 4 squared. Here we want to pull out anything that's in common, the biggest number in common. That happens to be 8. They both divide by 8. So it'll leave me with x minus 3. Here is standard form. So it's in that 4p form. You can go ahead and rewrite it with the 4p if you want. So y plus 4 squared equals 4 times 2, x minus 3. I'm okay with either of those. I would prefer you go ahead and multiply them and leave them as that 8, because then the next thing I'm going to ask you to do is tell me where the vertex is, what p is, and what direction it opens. So even if you don't do this step, you're going to end up telling me that information. So you're going to tell me the vertex is at positive 3, negative 4, because we always go x then y. You're going to tell me that p is equal to positive 2, because 4 times positive 2 is equal to 8. And then you're also going to tell me that this graph opens to the right, because my y term is squared and my p value is positive, so we know that it opens to the right. Next, we're going to look at finding all points of intersection. So I'm going to give you a circle and a parabola. So the circle equation I'm going to give you is x squared plus y squared equals 13. So it would have a center at 0, 0, and a radius of the square root of 13. Parabola equation, which we're going to write as y equals x squared minus 7. Now this is not standard form, however, I'm trying to make your life a little bit easier by not making you convert it into x equals or y equals. If you notice, we have x squared and y squared on my top equation, only x is squared on the bottom equation. So since not all x's and y's are squared, our only option here is substitution. So we're going to be taking x squared minus 7 and plugging it in for y. So as we go through and do this, we will have x squared plus x squared minus 7 squared equals 13. We're going to do some foiling, but notice we're going to be foiling x squared minus 7 times x squared minus 7. We're going to need to be careful about multiplying those out together. So we still have x squared. Then we're going to have x squared times x squared, which is x to the 4th power. X squared times negative 7, which is negative 7x squared. Negative 7 times x squared, which is negative 7x squared, so we know we'll be combining those later. And then negative 7 times negative 7 is just positive 49. Oops, 49, which is equal to 13. Now if we combine like terms, here this is my only x to the 4th, so we have x to the 4th. We have negative 7x, which would be negative 14x squared. Negative 7x squared and negative 7x squared. That's negative 14x squared, but we also have this positive x squared. So we've got positive x squared, negative 7x squared, negative 7x squared. So negative 14x squared plus x squared is negative 13x squared. And then we have plus 49 equals 13. We need to set this equal to 0. We've got lots of things happening, so we want to set it equal to 0 so we can factor. So we're going to subtract 13. So we have x to the 4th minus 13x squared plus 36 equals 0. We want to factor this. Now, we have not factored things that have an x to the 4th power. However, you notice we have an x to the 4th, an x squared, and a number. Normally, we have an x squared, an x, and a number. So all we've done is we've just squared all these things. Instead of having x squared, we have x to the 4th. Instead of having x, we have x squared. Instead of having a number, we just have a bigger number. So we're going to solve this the exact same way we would factoring normally, except instead of my first terms just being an x and an x, they're going to be an x squared and an x squared. So we're still looking for what multiplies to be 36 and adds to be negative 13 because each of those middle terms are going to be an x squared factor. Instead of just an x, they'll be an x squared. Just like they were up here in this line, we had an x to the 4th and then x squared terms and then a number. We're going to do that same thing. We're just going to go in an opposite direction. So we're looking for what multiplies to be 36 and adds to be negative 13. If we think about things that multiply to be 36, we've got 6 and 6, 12 and 3, or you can think about 9 and 4. They need to multiply to be positive but add to be negative. So if both terms are negative, negative 9 times negative 4 is positive 36. Negative 9 plus negative 4 is negative 13, so they're our winners. So we're going to have x squared minus 9 and x squared minus 4 as our factors. Now, if you think about both of these, if you look at x squared minus 9, that actually factors out more. That's a difference of squares. So that'll factor to x plus 3, x minus 3, because positive 3 and negative 3 multiply to be negative 9, but add to be 0 because we don't have that middle term. X squared minus 4, much the same way, will factor to x plus 2 times x minus 2. All of that is still equal to 0. Now we can go through and get our solutions. You can see we're going to have a few of them. So we know that x is equal to negative 3, x is equal to positive 3, x is equal to negative 2, x is also equal to positive 2. Remember, we're looking at intersections. Our answers are always going to be written as coordinate points. So our x values, one's negative 3, one's positive 3, one's negative 2, one's positive 2. And then we need to plug in to solve, we need to plug in and solve for our y terms. If we come back up here to this y equals x squared minus 7, so if we plug in our either negative 3 or positive 3, remember when you plug in either positive 3 here or negative 3, either way you're going to get the same number. So our 3 squared minus 7. So for both of our 3's, positive and negative, we'd have a positive 9 minus 7, which is 2. So this will be the point negative 3, 2, and 3, 2. So negative 3, positive 2, and 3, positive 2. When we plug in our 2's, again, whether it be positive or negative, minus 7, we'll have 4 minus 7, which is negative 3. So we'll have negative 2, negative 3, 3, and 2, negative 3. So there are 4 points of intersection. Really, the only difference that has occurred here is this step right here where we have to factor with an x to the 4th. You factored the exact same way, just those leading terms happen to be x squareds instead of x's.